Let's look at some problems where we'll set up a system of equations that we can use to solve the problem. In 2012, a 2011 Acura RL cost about $37,120, and a 2011 Chevrolet Impala LS sedan cost about $14,050. The RL depreciates or decreases in value by $4,245 per year, and the Impala depreciates by $1,200 per year. When will these 2011 cars have the same value? So to figure out when they have the same value, we're going to find a function we can use for the Acura's value and a function we can use for the Chevrolet's value, and then we'll set them equal to each other. Now the Acura's value starts at $37,120. And then since it depreciates by $4,245 per year, it's going to decrease by that amount per year. So we will subtract 4,245 times t, which is our time in years. Notice for this problem, our starting year is going to be 2012. Now the Chevrolet has a starting cost of $14,050, and it depreciates by $1,200 per year, so we subtract 1,200 t. Since we want to figure out when these values are equal, we'll set these formulas equal to each other. 37,120 minus 4245t equals 14,050 minus 1,200t. And there are several things we could do to solve this here. I'll add 1,200t to both sides. And subtract 37,120 from both sides. On the left side, negative 4245 plus 1,200. We have negative 3,045 t is equal to, on the right side, 14,050 minus 37,120. We have negative 23,070. Now if we divide both sides by negative 3,045, takes a minute to type all these numbers into the calculator, we get t is 7.576, or if we want to round this off to a whole number, we would say it's about 8. Since our starting year is 2012, 2012 plus 8 years is 2020. So 2020 would be the year when those cars have about the same value. If you'd like to try the next problem on your own, pause and resume when you're ready to see the solution. In 2017, so that'll be our starting year for this problem, a 2016 GMC Acadia cost about $33,763, and a 2016 Acura MDX cost about $43,868. The Acadia depreciates by about $37,038 per year, and the MDX depreciates by about $5,275 per year. When will these 2016 cars have the same value? So a formula we could use for the GMC car, it starts at $33,763. And then it depreciates or decreases by $37,038 per year. So we would subtract 37,038t, where t is going to be time in years since our starting year of 2017. then a formula we could use for the Acura, it has a starting value of 43,868. It depreciates by 5,275 per year. So we would subtract 5,275t. And to figure out when these are equal, we would set these functions equal to each other. And there's a lot of different things we could do here. I would start by adding 5,275t to both sides. And then I would subtract 43,868 from both sides. Oh, I did that wrong. Oh, it's not. Since I got rid of the variable on the right side, I need to get rid of the number on the left. So I'd subtract 33,763 on both sides. Sorry about that little error. So here on the left side, 5275 minus 3738, we have 1,537t is equal to, on the right side, 43,868 minus 33,763. We have 10105. To finish, we divide both sides by 1,537. Giving us t equals 6.574, or rounded to a whole number, it's about 7. Since our starting year is 2017, 2017 plus 7 tells us that 2024 is the year when those cars would have about the same value.